Hi, and welcome to section 5.1 using fundamental trig identities. We are going to use trig identities to evaluate trig functions, simplify trig expressions, develop additional trig identities, and to solve trig equations. So that's what's coming up. First thing that you need to do is make sure that you get this table in your notes. All of these are fundamental trig identities. The reciprocal, where you put one over another identity. We have our quotient identities, the Pythagorean identities. This guy right here is very important. Make sure you have him memorized. You can always derive these other two by dividing this one by sine squared or cosine squared, but this one you have to memorize. Here we have your cofunction identities, where you have cofunctions of complementary angles are congruent. And then here we have our even odd identities. So take a couple minutes and make sure that you have all of these in your notes. What we're going to do here is we are going to use trig identities to solve these examples. We've done this before using triangles, but what we're going to do right now is we're going to go ahead and use identities. We have that secant u equals -3/2, and our tangent is greater than 0, and we have to find all 6 trig functions. This means that our cosine is negative, and since our tangent is positive, that's going to put us in the quadrant over here. So our cosine will be negative, and our sine will be negative, and that will make our tangent positive. First identity that we're going to use is a reciprocal identity, and the cosine is equal to 1 over secant. So 1 over -3/2, and that's going to give me -2/3 for my cosine. The next thing that I'm going to go ahead and find is my sine, and so I'm going to go ahead and use a Pythagorean identity to find this. And I'm going to use that fact that sine squared u is equal to 1 minus cosine squared u. That gives me sine squared u is equal to 1 minus -2/3 squared. That gives me 1 minus 4 over 9. And finally, that leaves me with 5 over 9. That is sine squared, so I have to take the square root of both sides, and I get that sine u is equal to the square root of 5 over 3. So down here now we have and remember that you're in this quadrant over here, so that has to be negative. So my sine is negative square root of 5 over 3. I already know that my cosine is -2/3. Now I can find my cosecant by taking 1 over sine. That will give us 1 over negative square root of 5 over 3. So when I multiply top and bottom by the reciprocal of my fraction on the bottom, I get -3 over root 5. Got to get rid of that square root on the bottom. And that leaves me with -3 root 5 over 5 for my cosecant. And remember, I already have my secant. That is -3/2. The only one that I have left now is my tangent. And to find that, I'm going to use one of my quotient identities. Tangent is equal to sine over cosine. I have my sine as -root 5 over 3 over negative 2/3. And that will give me my tangent. When I multiply the top and bottom by negative 3/2, I'm going to get a positive, and I'm going to have, let's see, so I'm going to multiply top and bottom by negative 3/2. So those 3's are going to cancel, and I end up with a positive √5/2 for my tangent. My cotangent, using my identities, is 1 over the tangent. That is equal to my cotangent. And so when I multiply the top and bottom by 2 over √5, I end up with 2 over √5. Have to get rid of that square root on the bottom. So I multiply by my convenient form of 1 here to give me 2 √5/5. This next example asks us to simplify these two expressions. Let's look at letter A. I hope you guys notice that you can factor a sign out of both terms here. That's what I'm going to do first. I'll start out by writing my expression. So I have sine x cosine squared x minus sine x, and that is equal to, I can divide both terms by a sine of x, and I'm left with cosine squared x minus 1. Hopefully you notice that this looks very much like a Pythagorean identity. Let's see if we have it up here. Here we go. Sine squared is equal to 1 minus cosine squared. Ooh, what's wrong there? Well, I need to change the sign in here. So if I pull a negative out, giving me negative sine x, that's going to change the sign of both things inside my parentheses to end up with 1 minus cosine squared x. Now this guy, from above you can see that that is equal to sine squared x. So I'm going to substitute sine squared x inside of my parentheses. And that gives me a final answer of negative sine cubed x. So this guy right here simplifies to negative sine cubed x. Let's take a look at this one right here. Well, I really, I like cotangent, but let's go ahead, and I see lots of sines and cosines, so I'm going to write everything in terms of sines and cosines and see where that leads me. So we have sine t plus cotangent t cosine t. They want us to see if we can get this to be a little bit simpler. So I'm going to leave the sign there. I'm going to rewrite cotangent t as cosine t over sine t. And then I'm going to I have this cosine here left. So cosine t. Now, I want to make this simpler, and I have two terms here. So my goal would be to get this to equal one term. I need a common denominator in order to add fractions, so I'm going to multiply this term by sine over sine. So let's go ahead and just kind of put over onto the side here. I'm going to multiply that one by sine over sine, which is just 1, and that's going to give me a common denominator. Now I have sine squared t over sine t plus cosine squared t over sine t. And I hope you're seeing that this is looking good. Now we have sine squared t plus cosine squared t all over sine t. I see one of my favorite Pythagorean identities right here on top. And sine squared plus cosine squared, you can substitute. That is equal to 1. So I have 1 over sine t. And I usually don't like to leave my final answer as a fraction, so I would write that as cosecant of t. Much simpler than the expression that we started out with up there. I have one more quick example. And sometimes when you're, okay, they want us to factor this. This looks to me like a, I need to get something the same here because I can't factor when I have cosecants over here and cotangents over here. So I'm going to have to rewrite in terms of something that's the same. So sometimes factoring or simplifying can best be done by first rewriting the expression in terms of just one trig function. In this case, I know that, whoops, sorry about that. I know that that cosecant Hi, sweetie pie. It's like 43. Okay, now keep in mind, honey, you're going to have to leave early because the roads are really slippery. Okay? So 5 more minutes. Okay, bye. I can rewrite this term right here using one of my Pythagorean identities. I know that cosecant squared x is equal to 1 plus cotangent squared x. If I substitute this up here in my expression, then I have only cotangent here, which is exactly what I want to have. So I'm going to substitute this for cosecant squared. So this guy is now equal to cotangent squared x minus cotangent x. Now I have a plus 1 here and I have a negative 3 here, so that's going to give me negative 2. Now I have something that looks suspiciously like a quadratic, and I'm going to factor it exactly as I would in x squared minus x minus 2. I'm going to draw my 2 sets of parentheses. The term that has to go first will be just cotangent x. And then this 2 right here, I will have a negative 2 and a positive 1. And then I always check I do a little quick check. So my first gives me my cotangent squared. My outer and my inner combined give me plus cotangent x minus 2 cotangent x, which is negative 1 cotangent x. And then my last gives me a negative 2. This concludes our lesson for the day. If you have any questions, please bring them to class. We will practice doing these in class and practice, practice, practice.